Okay, chapter 28 is percentages. So after reading through this chapter, learning and practicing with the practice questions, the student should be able to define the term percentage strength, determine how much solution can be prepared from a given weight of ingredient to make a specific percentage strength concentration of the solution, calculate the amount of an ingredient present in a volume of solution when the concentration of the solution is expressed in percentage strength. Determine how much of a concentrated solution is needed to prepare a medication. Order for a more dilute solution when strengths of the concentration solution and medication order are expressed in percents. So the strengths of many solutions are expressed as percentage. For example, 0.9% sodium chloride injection or 5% dextrose injection. So a solution is going to be composed of two parts, the solute and the solvent. Okay. The solvent is the substance, usually a liquid, but it can be solid, in which the solute is dissolved. The solute is the substance dissolved by the solvent. The percentage strength of pharmaceutical compounds is represented by a given weight in grams of a drug, solute in milliliters of solution. So, for example, 1 gram in 100 milliliters would be the same thing as 1%. Okay. So if you look here at your paper, you have or at the board here, you have dextrose injection 5%, which is also known as D5W. It contains, because the 5% would be always grams. So it'd be 5 grams of dextrose, and it always, because a percent, when you do a percent, you take it out of 100, so out of 100%, out of 100 milliliters. So if they just give you 5%, you know that that is 5 grams over 100 milliliters. Okay, so your percent is always going to be in grams, and its percent is always out of 100 milliliters. So if you go to your practice problems, these are actually going to be probably pretty easy for you because you're already used to ratio proportion. So all it is using percentages into ratio proportions. Okay. So number one here, he says how many grams of amino acid are in 500 milliliters of 8.5% solution. So this is our given stock. And we have 8.5%. Remember, it's always grams. And underneath it, this percent sign means you would always have 100 underneath it. So it's always out of 100 milliliters. See, it's supposed to say X grams. So we have weights up here. We'll have weights over there. So it'll be X grams of amino acid are in 500 milliliters. Okay. Then we always double check our units, make sure they're the same on top and the same on the bottom. So grams, grams, milliliters, milliliters. Cross multiply. Whatever you multiply the x by always goes on the bottom. So x times 100 would be 100. 8.5 times 500 is 4,250. You divide that and it comes to 42.5 grams. Number two, what percent, so it's asking a little bit different. So what percent, so we know we're going to have X percent, okay? And because we know we have X percent, what I always going to do is, what I told you earlier, is out of 100, so we automatically would put 100 milliliters underneath it, okay? So what percent solution would result if you mixed 3 grams of your sodium chloride that's supposed to be in enough water to make 25 milliliters. So our 25 milliliters would go on the bottom, and our 3 grams would go here. And your percent is always grams. Okay, so you just cross multiply. 3 times 100 would be 300. It goes on top. Whatever you multiply the x by, 25 times x would go on the bottom. So 300 divided by 25 becomes 12. So your answer is 12%. Number 3, a powder drug comes in a vial containing 2.4 grams. If the total volume after the diluent is injected is 6 milliliters, what is the percent of the strength? So again, it's asking what is the percent. So X percent, we know that's always going to be grams. And because of the percent sign, you're always going to put 100 milliliters underneath it. Okay. So then we have 6 milliliters and 2.4 grams. And again, our units are the same on the top and the units are the same on the bottom. So then all we have to do is cross multiply. X times 6 would be 6. 2.4 times 100 would be 240. 240 divided by 6 would be 40. So your answer is 40%. Number 4, a patient medication order calls for a liter bottle of acetic acid irrigation solution of 0.25%. How many milligrams of acetic acid are contained in each 30 milliliter irrigation dose? So on this one, I wanted to point out the liter because that's going to give you, some people would probably look at that as a number, but it's too much information there. So you don't even have to worry about that one. So it's wanting to know how X milligrams are contained in 30 milliliters. Okay. And then our given is our 0.25%, which is grams. And because your percent is always grams, and you always put 100 milliliters underneath it. Okay. So now we look, our liquids are the same units, but our weights are not the same units. So you would have to change our grams to milligrams. And we do that by multiplying 0.25 by 1,000, and you get 250 milligrams. So you cross multiply. Whatever you multiply the X by always goes on the bottom. So that would be X times 100 be 100. 250 times 30 was 7,500. Okay, and if you want to do it the easy way, you can just take out the 2 zeros, and 75 over 1 would be 75. So 75 milligrams. Number 5, you have dissolved 170 grams of a drug in 1 liter of water. What is the percentage, so this will be your X, strength of the solution formed? So we know our given, or what we're trying to find is X percent, and percent's always grams. Okay, anytime you have the percent, it always gets 100 milliliters. Okay. Then we have 170 grams over 1 liter. So our units the same are on the top, but on the bottom our liquids are different units, so we have to change that. So to me it's easier to change the liter to milliliters because we could just multiply it by 1,000. So it'd be 1,000 milliliters. Then we're going to cross multiply. 170 times 100 is 17,000. X times 1,000 be 1,000. Again, we can be this easy way. Take out our zeros, 3 on top, 3 on the bottom. 17 divided by 1 is 17. So your answer is 17%. Okay, now next on page 232, okay, you have number 8. Okay, it says how many milligrams, so we know we're going to have X milligrams of zinc sulfate are found in 4 ounces of a 0.02% solution. So your 0.02% would be in grams, and because it's a percent, we automatically put 100 milliliters underneath it. Okay, so then we have to check. We have our units, but on top are weights, but they are not equal or the same. So we need to take grams and convert it to milligrams. So it would be 0.02 times 1,000, which would be 20 milligrams. And over here, we have ounces and milliliters. And to me, it's easier to change your ounces to milliliters. Because remember, if you have 1 ounce, it's equal to 30 milliliters. So 4 times 30 would be 120 milliliters. I usually always use the rounded version. So X times 100, it always goes on the bottom, so be 100. 20 times 120, be 2,400. Again, take your 2 zeros out. 2 on top, 2 on the bottom. 24 divided by 1 is 21. 24 divided by 1 is 24. So your answer is 24 milligrams. Number 9, you have a solution of ampicillin that contains 250 milligrams per 1 milliliter. So that is your given. Calculate the percentage strength. So it's asking for X percent. So it'd be X grams. Remember, when you have a percent, it always gives you, it already has 100 milliliters. So you have your 3 parts. So X times 1 goes on the bottom, would be 1. Oops, and then wait a minute, I almost forgot to check our units. So 250 milligrams we need to convert to grams, okay? So you would, of course, you would divide it by 1,000 because we're going backwards. So if you're going from milligrams to grams, you divide 1,000. If you go from grams to milligrams, you multiply 1,000. Okay. So this would be 250 milligrams divided by 1,000 is 0.25 grams. Okay. So 0.25 grams times 100 milliliters, of course, would be 25. 25 divided by 1 would be 25%. Okay, next, asking you how many milligrams. So we know we're going to have X milligrams of certified red color should be used in preparing 5 liters of a 0.01%. And some people where they get messed up is they go, oh, I don't have 3 numbers. But remember, percent is always grams, and you always have 100 milliliters underneath it. Okay. So if you look at your units, you have milliliters, liters. So those are different units. So you have to change your liters to milliliters. So again, the easiest way to me is you multiply it by 1,000. So it'd be 5,000 milliliters. And you're looking for milligrams, and this is grams, so you have to convert your grams into milligrams. So again, grams is going to milligrams, so you multiply it by 1,000. So 0.01 times 1,000 is 10 milligrams. So X times 100 always goes at the bottom, so it'd be 100. 5,000 times 10 is going to be 50,000. Again, take out your zeros, make it easier. 2 on the bottom, 2 off the top. And you have 500 divided by 1 would be 500 milligrams. Okay, and these are pretty easy. They're all the way, pretty much all the simple problems are like this in your book. So if you have any questions, just send me an email, and I'll be glad to make an appointment to help you if you need help.